just realized that I'd left out some stuff on batteries. Batteries take up both room and take up weight. So you have to have space for these things. I'm getting glare in my eyes, so back to these. You have to have space for the batteries, and you have to be able to take the weight. I mean, if you go on to spend real good money, you can put lithium LiFeO batteries in, lithium ferrite oxide, whatever. They're really nice, but they charge very differently than a normal lead type battery, like a wet cell or an AGM, which have or even a gel, which I don't recommend gels, because gels, they're just a marine battery. AGMs are superior in all ways. But you want to have, with lithium batteries, you need to have updated software on all your chargers, because they need to be charged very well. And the nice thing about them is that you can take a lithium battery down to only 20%. So you've got a 100 amp hour lithium battery, you can use 80 amp hours out of it. And that 100 amp hour battery is a little smaller and lighter in weight, and a lot lighter in weight than the equivalent 100 amp hour battery. So you can put in this physically lighter space, smaller area amount of battery and have equivalent or better battery power. Plus they really can provide they can take a charge very fast. So if you're running a generator to charge them, they'll charge up much faster. They also can take a discharge quite nicely, so you can pull a lot more out of them at once. That's why they make little batteries this big that you buy for $50 that will have jumper cables attached to them. They're lithium, and they will jumpstart your car. So they can provide a lot of load in a very small space. But that's an obscure subject. We have lithium batteries, and they're a little bit persnickety, and I would not recommend to anybody who really doesn't understand what they're doing. But they're great, and they're expensive. $600 or so per 100 amp hours, as opposed to $280 for a golf cart AGM, and maybe $90 to $150 for a golf cart wet cell. Let's talk about how to reduce the load on your batteries. And I've touched on this in a lot of ways. Well, one of the obvious things is you need lights, so you go to LED lights. Use a lot less power. If you want good light, you can't get the smallest LEDs everywhere. A buddy of ours was a single guy. He replaced all of his lights with LEDs, and he bought the smallest, lowest power usage of every single LED. So when he turned them all on, it looked like it was a little bit better than twilight inside of his RV. For some reason, every time he tried to get some woman to spend time with him, they always complained that it was too dark. They couldn't read into these things properly. They didn't like the lights he was getting. And he was real depressed because he was trying to save so much money, so much power by making his LEDs as small as possible. So my advice is be realistic. Try to have it so that you have ability to have about as much light as you really, really need. If you're too frugal with LEDs, you might not have as good experience. But LEDs are the solution for lights. They just are. They are more efficient than fluorescence and way, way more efficient than incandescents. And we've replaced most of our lights with LEDs, or at least the ones we use the most. Another use of battery power is your water pump. Can't do much there. Water pump it needs to pump. They're not that inefficient a product. They do the job. You have to live with what you get. Can't help you on the water pump. can't really help you on reducing the amount of power usage of the electronics in your hot water heater or, your air, or anything else that's needs to run. Refrigerators, the ones with ice makers, use more battery power than the ones without ice makers. That might be something you can fix, but it's probably something that's too painful to fix. You can solve the furnace problem, which I've helped as the furnaces, by using a radiant heater. You can get radiant. There's 3 kinds of propane radiant heaters. There's catalytic, ceramic, and blue flame. And both ceramic and blue flame actually have a fire. Blue flame has just got it behind something. Ceramic has got a fire that's making bricks warm and pointing. Catalytics are more expensive. To create a catalytic reaction, you have to be more particular because they've got to make sure the cloth stays clean, or you end up having to replace it, which is an expensive process because but you can put a piece of paper against a catalytic heater. It's warm to the touch, maybe a little hot, but it's not burning hot to the touch. It's close to boiling water temperature, so it could burn you, but it's not as bad as a real flame. All 3 of these though, since they're not vented, you have to give some fresh air, you have to crack a vent, you have to crack a window, you have to do something to make sure that they're venting a little bit, because they use oxygen and they put out byproducts. You can smell them. Some people react to those byproduct chemicals strongly, others doesn't bother. The oxygen depletion can be a problem. Nice thing about the ceramic and blue flame heaters normally have an oxygen depletion sensor. You can get around 6,000 to 7,000 foot elevation. They won't work, or they work unreliably. Get above that, they don't work at all. Catalytic heaters don't have this problem because they're using a chemical catalytic reaction to generate the heat. They can go up to about 12,000 foot elevation. So if you're going to go in the mountains of Colorado, get a catalytic, you've got to pay more money for it. Problems with catalytic is, as I said, they're more persnickety. You have to keep them clean, don't let them get dusty. They are either on or off. They normally have 2 settings, low and high, and you put them on, while the ceramic heaters can often be programmed thermostatically or just have cycled, or other things that allow them to cycle on and off so they aren't running all the time. The advantage of these kind of heaters from a battery viewpoint is they don't use any battery. The advantage, and they also have a great advantage in propane. They're almost 100% efficient, while the forced air furnace in your RVs are normally about 60 to 70% efficient. So you're blowing a lot of hot air out with your exhaust in a normal. But you aren't putting in any strange chemicals inside. You aren't depleting any oxygen. You aren't adding combustion chemicals from the burning of the propane inside the RV. So that can save you a lot of electrical use. So that's how you save battery power. LED lights and going to radiant heating systems. And the nice thing about the catalytics is that you can touch them, so a pet can walk and rub against it and not have their hair set on fire. You aren't probably going to have a fire issue. You're just going to have chemicals in the air and oxygen being depleted a little bit. So you have to watch for that. It's best to have a CO detector for that. It's not that CO, carbon monoxide, is not the only thing that they put out, but most of the stuff is somewhat proportional. As if you get CO, you want something with a digital readout on your CO detector, so you can look at it and say it's putting out 2 parts per million. You don't want it to be sitting there at 100 parts per million. You want it very low, 0. Ours, normally we have 2 of them, and they normally say 0 when we're running our ceramic heater, so it's not a big problem. But we do smell the combustions. We can smell that something's being left in the RV. But when we boondock, we can use the heater. And we also can use it just to keep our propane usage down, so we'll often use it when we're just trying to heat the place. And when we have to use propane, because it will not use that much propane. The downside of using these kind of heaters against your forced air furnace, the forced air furnace normally does some heating of your basement bays. And you might, if it's really cold, you're going to want to run your main forced air furnace to heat your basement bays. And my advice is, if you're going to live that way, somewhat permanently, you put the skirt the rig, do all the other things you need. And if you're only going to be doing it temporarily, move where you're not going to be in that cold weather. RVs are not really that great about cold weather. These people do stay in cold weather, but they normally take a lot of effort to be in cold weather. They normally skirt them with thermal skirting or with hay bales. They normally put in big external propane tanks. They put bubble wrap in all their windows to extra insulate them. Do a lot of crazy stuff to maintain the winter. And my view is it worth it? You have to make the decision. I can't make the decision for you. But anyway, that's how you mitigate your electric uses out of your batteries. And you can do a little bit of reducing your consumption. Don't have lights on, don't do this, don't do that. But mostly it's LEDs and radiant heaters. Hope that helps.